So my name is Chris Thalinger. I work for Twitter. I live in Hawaii, and I'm very happy that I can be here in Istanbul to talk a little bit about Twitter and Growl. First, most important question, is there surf in Istanbul and are surfers in the room? Oh no, that sucks. You guys have to move to another city. That's annoying. I thought that would be the case. Anyway, so I'm here to tell you a little bit about the story, the work I was doing when I joined Twitter with Graal. So first, Twitter has a small VM team. It's like, we have a little more people now, but it's like a group of 4 core people that are JVM engineers, and there are 3 GC engineers that take care of all the GC issues we have with all the microservices, and then there's a compiler engineer, and that's me. So I'm the only guy doing compiler work there. And if you're going, yes, next question. Who has a Twitter account? Yeah, that's pretty good. All you other people create one right now. If you're going to tweet about this talk, and I hope you do, take pictures, and then please add the Twitter VM team hashtag so that that my other team colleagues know that I was actually here, and not just making stuff up in surf and, but there's no surf, so probably not. So please add that hashtag and tweet about the talk. So what's the goal of this talk? It's like the title is very punny and it doesn't really tell you what this talk is about, right? So this talk is about saving money. And I think that's very important and everyone likes it because most people like money. I don't know how you feel about that, but I like it. So I'm going to tell you about this. And before I do this, I tell you a little bit more about myself. So my name is Chris. I work for Twitter now, but I'm working on JVMs for over 13 years. And most of the time, pretty much all the time, I was working on compilers. Jit Compiler, so just-in-time compilation. I'm going to ask you a few questions here in the beginning now. So who knows what a Jit Compiler is? Yeah, okay. So in a nutshell, basically, a Jit Compiler is part of the Java virtual machine, and it takes Java bytecode and translates it on the fly while you run your application into native code. So because Java virtual machines usually start out interpreted, so you're interpreting your bytecode, which is very slow, and then at one point you want to move to native code that you actually run fast. That's a Jit Compiler. So I was working on Jit compilers for over 13 or 14 years now, basically. And back in the day, I was working on a different JVM implementation at the university, and we were all working on GNU ClassPath, so I'm going to call out old people now. Who remembers GNU ClassPath? No old people here? Yes, 1. Excellent. So that was back in the day before some microsystems open sourced Java. And we all met up at FOSDEM, this free open source developers conference in Brussels, and drinking beer, and we all hated Sun because they were the bad guys and we were the Wild West and trying to liberate Java. And then they showed up and said, "Hey, here's the code," and we all thought, "Oh, great, cool." But we became friends soon, and then I started to work for Sun, which was great. I loved Sun, great company. Then Oracle acquired Sun, and I was always part of the Hotspot compiler team. So I was working on mostly C2, but a little bit C1 as well. So who knows what C1 and C2 are? So, okay, there's no hand. So Hotspot, you know what Hotspot is. Okay, Hotspot is the JVM of OpenJDK. And Hotspot has 2 Jit compilers. One is called C1 or client compiler, and the other one is called C2 or server compiler. You might have heard client and server. So they are called C1 and C2. And so C1 is a high throughput compiler that produces code quickly, while C2 is a highly optimizing compiler producing peak performance code. Okay, so I was working most of the time on C2. And then the biggest 3 things that I was working on while at Sun and Oracle was JSR 292, which is support for dynamic languages in Invoke Dynamic. So John Rose and I, we were working on this for quite a while. I was writing most of the compiler support, a little bit of interpreter support, porting it to Spark, and so on, things like that. And then we did another re-implementation of that, which we moved a lot from the VM into Java land, into the core library, so there was a little bit of API work going on in the core libraries. I did that too. So technically, if it doesn't work, you could blame me. But a lot of people touched it after me, so I would say they introduced the bugs. So everything I did was okay. Then we're going to JDK 9 now. We were introducing Chap 243, which is the Java level JVM compiler interface, and that's important for this talk as well. So this interface is in the JDK, in OpenJDK since 9, and through that interface, you can basically plug in Graal on the side and then use it, either as a module that's part of the JDK or an upstream build you do yourself. You clone it from GitHub, you build it yourself, and you plug it in, you turn it on. There's another talk I do. I'm not doing it this year here, but you can watch it on YouTube, and it will basically explain to you how to do that, how to use it, and what the pitfalls are. And then the last big thing I did at Oracle was Chap 295, which was a ahead of time compilation. So it basically takes Java class files or a jar file, and it compiles it statically ahead of time into a native library, basically, that the VM then can load in and run from that code. And that Chap 295 implementation uses Graal as the code generating backend. So it's using Graal. It's basically a Java application, more or less, because Graal is written in Java. It's a Java application that loads in classes and then spits out shared libraries. That's all it does. Yeah, and now I work at Twitter. It's great. Love it. It's amazing. Great company. So you guys know what Twitter is, right? It's a huge distributed system. We are using microservices. Most of our microservices, except a select handful, are written in Scala. And so tons and tons of microservices. I don't even know how many, in the hundreds. And they're, the most important ones are the tweet service, which basically reads and writes tweets, the user service, and timeline service, builds up your timeline, shows it on your phone. Social graph meets, all the edges you have between your followers and who you're following. These are kind of the most important services we have and the biggest ones. We have services for everything else, for direct messaging, for links, for images, you name it, everything. So we have, depending on the service, right, but especially tweet, social graph, and user service, we run many, many JVMs per service, like thousands of instances of that service. And so we are running these thousands of instances on thousands of JVMs on thousands of machines, so tons and tons. And we have multiple data centers. So the operation is pretty big, okay? And the expense for this is also pretty big. The more machines you have, the more money. And so we're trying to reduce that. Twitter likes open source. So we're doing a lot of open source. We are using a lot of open source technology, but we're also doing a lot of open source. There's this twitter.github.io thingy where you can go to and you see all the projects we have open sourced. Finatra is one of the examples I can remember, and I think I'll bring it up later. It's basically like this framework that we use to build most of our microservices. So take a look. So for us, Graal is a good fit because it's open source, right? So we can just take it and play around with it. We have the ability to fix bugs if we have to. That's one of the main reasons why Twitter has a VM team, to be able to react to an issue soon and quickly. And so we're using Graal, and we're also contributing some code. I'll give you an example later, one thing we did. So since we have our own JVM team, and as I said, we're doing a lot of support, and we want, if there's an issue, the turnaround should be quick. So we're building our own JDK, which is based on OpenJDK 8U. There are a few additions to that. So earlier I said Chap 243, JVM CI was added in JDK 9, but we're still running on 8. So we had to backport that to 8. We did that. We added Growl, basically, because OpenJDK doesn't have Growl, so we cloned basically upstream and made it part of our build, so we have it in there. We have something still, but that will go away pretty soon. Something called Contrail, which was a JFR replacement, but, oh, I'm doing this. Okay, sorry. But JFR, Oracle open sourced everything, or will be, right? And JFR is one of the next things, and then we'll just port whatever we had additionally over to JFR and then use that. And we had a few CMS improvements a while ago, but I think all of them are now upstreamed, so there's nothing there right now. So why Graal in general? C2, as I said, is very old and very complex. So the learning curve is very, very steep. And personally, in my experience, when I started working on C2, it took me between 3 and 4 years to fully understand how it works, because it interacts with everything in the JVM, and that's a very, very long time. We had this issue at Oracle that some people left, and then we had to hire new people, and these new people came in, and these days people, you look at code on GitHub or I don't know what, and then you think, oh yeah, in a few weeks or maybe 1-2 months I'll understand how this all works. That's not the case with C2. And so people get frustrated because they come to us to say, okay, cool, I'm working on Hotspot now, and then they don't understand, they don't know what's going on, and after a while they think, oh, I don't know, am I stupid or what the hell is going on? So we lost people because of this. Before they were really useful to us because the training, it takes so long. That's one big issue. The other is that in the last couple of years, there were no new optimizations really to C2. There were a few optimizations on the intrinsic level. I don't know if people know what intrinsic is, probably not. It's a very good example that I always use is string.indexOff. There's a Java implementation for it in the core library, but it's pretty slow, and the compiler can't do a lot about it, but you can handwrite optimized assembly code using AVX instructions, and that's basically an intrinsic. The compiler knows and replaces it with some highly specialized code. So a lot of that was done mostly by Intel, right? They were coming out with AVX 256, 512, and so on and so on. New intrinsics have been written, but this is not really what you want. You want a compiler to have new optimizations that apply to everything, the whole program, hopefully. That's what you want. So there was nothing done in C2 in the last couple of years. And in my personal opinion, C2 reached its end of life a long time ago because it's so complex. No one really wants to touch it anymore because it works well right now, pretty much for all of the world, right? It has been tuned to this. So that's an issue. So Graal, on the other hand, is much easier to understand. It has a very modular design. I don't know, it's kind of a little small here, and it's an older screenshot, but it's basically split up into what they call modules. It's a little confusing. It's not Java 9 modules, but it's kind of package-based modules, and the build system that Graal is using makes sure that there are no circular dependencies and no violations of dependencies between packages and so on and so on. So it's very modular designed. It's also written in Java, which I should have on this slide, I guess. So some people might say, yeah, it's easier to understand than C++. I think it is. And then very, very important for this talk as well is Graal has a better inlining implementation and also a better escape analysis implementation. I'm not going, most people probably know what inlining is. I'm not going to explain what escape analysis now is because that would take too long, but we'll see a little bit later why this is very important. Okay, so I started to work for Twitter, and I said, hey, let's run stuff on Graal. And then, of course, we found a few bugs. That was expected. That was something I was actually hoping for, and that was one of the reasons why I went to Twitter, because I wanted to run Graal or use Graal with production code. That's really when you find issues, right? So I'm going to show you the few bugs we found. So this one, and there's a lot of technical information here, so if you don't understand everything, that's okay. I'm trying to explain most of it. So this bug was OSR compilations didn't work. That means on-stack replacement. I'm not going to explain how that works, but basically the exception or the log file output looked something like this: compile skipped, OSR with logs not supported. That's not good because you want the compile to actually happen, and the exception looked something like that. Since Graal is Java code, you get a really nice stack trace, and you know what the heck is going on. So there's an on-stack replacement phase that does that, and that didn't work for some reason. Okay, so I discussed this with one of the Oracle Labs engineers, Tom, and we decided at that time that it's not really a big issue because who knows what tier compilation is? Okay, so when I was talking earlier about C1 and C2, that there are two compilers, and Hotspot also has an interpreter, right? That's how you start running your code. There are tier levels you go through. Like you start out interpreted, you run there for a little bit, and then you compile with C1, and that code has code compiled in to collect profiling data. You run on that for a while, and then you recompile with C2 using the profiling data to produce good code. And so the tiering is tiered compilation, okay? So if for some reason you can't compile something on tier 4, which would be C2, 1, 2, 3 are different C1 levels, and 4 would be the C2 level. If you can't compile something on tier 4, it's not that bad because you can fall back to a lower tier and just compile it with C1. That's fine. And that was the case here. And since the method was, for us, not very important, it was not a super hot method and not important to the application itself, we decided that this is not a big issue because the method will be flagged and then not be compiled on tier 4 anymore, and you fall back on C1 code. It's totally fine. So, but it would be still good to have that fixed. So actually, someone then later, when we weren't talking about it anymore, someone fixed it. And it basically had like 1,000 lines of code, new code, that fixed that issue. Good. So then I tried to verify that everything works fine now. And it kind of did, except there was this other one that suddenly showed up, this no on-stack replacement node thingy. And so Tom and I would discuss this again. This is, by the way, just a screenshot of GitHub. You can just go there and read it all up, right, if you're really interested. So it turns out that should be a pointer here as well. Wow, great. So Tom says there's a little bit of logic in C2 parsers which allows access to static fields within the CL init. That's the static class initializer for classes which aren't fully initialized yet. That's an issue, right? Because you're accessing a static field in a static class initializer while you're still running and compiling it. So usually a static class initializer, well, means not usually, always runs once, right? Most of the time, you just interpret it because they're pretty simple, they are not doing a lot. So you're running once and then you're done. When you're compiling a static class initializer, it means it's doing a lot because it has to get hot. That means it's either a lot of code or it has loops in it, so it gets really, really hot. And you have to wait for the class initializer to be finished so you can carry on, right? Because you need the class to be initialized to actually then use it later when you want to instantiate an object or something. So it would be good if that would be fast. And for that, you need on-stack replacement, the thing we talked about earlier. So turns out that didn't work well, but C2 had a little bit of logic in there that does that, and it looks something like this. It's called static field OK in CL init. Excellent, right? And then the comment says, better to check now than to de-optimize as soon as we execute. And that's exactly the point. Do people know what de-optimization is? No. OK. Quickly, I should give a talk to actually explain all the things that I'm saying up here. De-optimization is you compile code, you have compiled code for it, and then you hit a point that you would not expect. Like sometimes they're called uncommon traps. It could be you hit a point where a class is not loaded, or you hit an if-then-else branch, and the else branch was never executed before. That's like an uncommon trap. And then you have to de-optimize from natively compiled code down into the interpreter. That's a de-optimization. And in that case, that would be the worst case situation, because you're starting out running the static class initializer, interpret it, it gets hot, you compile it, and as soon as you execute it, you de-optimize and fall back into the interpreter. That you want to avoid that. So there's a small method for this in C2, and as you can see, we fixed it was 31 new lines of code. So it was basically nothing, just a little bit of logic that was missing. Then we had this one. Ignore that long thing here. It was a segv. That's the important part. And the problem is, it took a couple days to actually reproduce that thing. So I was running our service, and then suddenly it crashed, and I didn't know where it was coming from. And then I was looking through our configuration files, and I noticed, OK, we're using something called Heapster. And Heapster is a GitHub project, and it's an agent library to do heap profiling. So you know what agent libraries are, what agents are, and heap profiling always means you're instrumenting new bytecodes, right? If you're creating a new object or a new array, you're profiling what type you're actually allocating. And in that case, so the thing is, Graal has something that's similar to what I explained earlier with intrinsics, but it's called snippets. And it's basically Java code that's being treated differently by Graal itself when it compiles itself. And that's more or less an intrinsic. And so you can express yeah, no, I shouldn't go too much into detail. But the most important part is that it's parsed differently. Okay, so there was a long discussion between Doug and Tom about this, and it turned out up here there was a snippet that used double value off, and double value off allocates an object. And so Graal just assumed and compiled code for this snippet, but then later the agent instrumented that code, and then that didn't match anymore. And that's where the crash was coming from, because the bytecode that was in the VM looked different than the actual compiled code. That was the issue. And oh yeah, and then Doug says, oh, it's time to bite the bullet. So that already, means, okay, that will be big. That was almost 2,800 lines of code. But it's important. So this never showed up before, because in testing, Oracle Labs was never testing with agents. But tons of people are using agents in the wild, in production, right? So this was very important to find. It was easy, it was not easy, but it was important to fix, and we did. And then there was this bug where I was logging, right? And in our log files, not the ones where the plain text passwords show up. So there was a lot of connection exceptions showing up, and I really didn't know where they were coming from. Because in a microservices environment, if something has a connection exception, you don't even know, is it you or is it the 100 others you're talking to? Who is the one that's actually failing here? So I had no clue what to do. And then independently, because I think we were upgrading from Netty 3 to Netty 4 or something like this, I thought, okay, it might be a good idea to run the Netty Netty tests. And so I ran them, and boom, Netty buffer failed. So, okay, we better take a look at that, what the issue was there. So it turns out, and this is a very, very interesting bug, there is something called reverse bytes. You might have used it like on the number classes, like integer, short, long, reverse bytes, just reversing bytes. And in this case, it was short.reverse bytes, and it was wrong. It produced the wrong result because there was a bug in the implementation of that reverse bytes plug-in, kind of something like a snippet, a lot of words basically that are the same thing. The crazy part about this is used all the time, right? Reverse bytes is used all the time, but just in this very particular case, it didn't work, and it crashed or failed. So this one was super easy to fix. It says 68 editions, but that includes a test case. So that was literally a 2-line fix. But it was important to fix that because there was a bug lingering somewhere that someone had to hit at one day, and it unfortunately was us. But it's fixed now. Okay. And that was it. These were all the bugs we found. Since then, nothing. And this is more than a year and a half ago now. So we are running Graal a lot, and there were no bugs since. So a little bit about the contribution we did. We knew we're still running on Java 8, but at some point we have to move on to 9 or 10 or 11, whatever you pick. And since JDK 9, there's something called compact strings, which might be very useful, especially when you do a lot of string-based stuff like tweets, right? So unfortunately, the implementation of compact strings was still done while I was at Oracle. And the way they decided to do it, because C2 was too stupid to optimize code that's written with unsafe, they decided to not do it with unsafe, but write handwritten intrinsics. So it means handwritten assembler code for all the platforms you're supporting and for all the compilers you're supporting. And so unfortunately, the implementation that's being done or is in Hotspot today, written in C++, cannot be used by Graal. So we have to port that code over. It's, it's stupid code monkey type of thing. You take assembly code and move it over into Java land, but someone needs to do it, right? So we have to port these as well. I started doing this. This is the benchmark that I was using to compare them. I started with the string.compare2 one. And I think the important one is like the third line here you see is like 2600 nanoseconds per operation. That was before, and then with the intrinsic it was 126. So this is exactly then the bottom table looks like the table with C2. That's the important thing. I'm not expecting any more performance here than C2, but we want the same, right? We want feature parity with C2. So that's something we did, and I did not have time to actually finish this up because I have to be at conferences to talk to you people. But Dimitri, fortunately, picked it up, and he added that. So it was about 1,000 lines of assembly code we had to port over. And there are still 3, 4 left, but they are much, much smaller. So we have to do that soon, before 11 comes out. That would be good. OK, now to the important part. Numbers. I'm going to show you a bunch of graphs, and I'm telling you a story about tweet service. That's the reading and writing tweet service that I was using to get all these performance numbers, because it's easy to run. So it's a Finagle thrift service, and Finagle is one of these open source things that we have, and we put out, and it's a extensible RPC system for the JVM used to construct high concurrency servers, blah, blah, blah. I don't even know what it is. So I said most of our services are written in Scala, and this one's written in 92% Scala. I cannot even write a single line of Scala code, really. But I don't have to. The only thing I care about is Java bytecode. That's all that JVM consumes. So I was using this. I had a test set up with dedicated machines, and the reason for that was to get very stable benchmark numbers, because if you run in the production data center, you have other stuff running on your machines, and then you have crosstalking going on, and so on and so on. So I had dedicated machines for this, one machine per instance configuration, and all the instances, all the machines receive the exact same requests. That's important. It's not only the same number of requests, it's the exact same request. And that's important because a tweet could technically be 1 character long or 140 or 280 today. So, and that makes a big difference in the allocation pattern. So they all receive the exact same requests. That's not that important. I just put it on the slide so people could technically, try that out. And then we run in the tiered compilation setup that I was explaining earlier, and it's using C1 and Graal. Instead of C1 and C2, we just switch out C2 with Graal, and Graal is then producing peak performance code. Since Graal is written in Java, there's something called like a bootstrap, which means when Graal has to be compiled as well, because it's not AOT compiled. So this is not, I'm not going into details here. My other talk would explain that. But for us, it's not an issue. It never has been an issue. And technically, if you are going to try it, and it's an issue for you, after JDK 9 and 10 is now the default, right, or the current one, you could AOT compile Graal, and then all that would go away. But for us, it's not a problem, so we're not doing it. OK, to the graphs. This is 24 hours of reading tweets. And you see their highs and lows, and you see at the bottom, x-axis, you see the dates and the times. You will notice there is no y-axis. And the problem is that's confidential information I can tell you. So you just have to take my word, and I made the graphs later so that we can talk about actual improvements, and you see what I'm talking about. OK, and then we have C2 in blue, and then orange is Graal, which you can see here a little bit. And then I also tested C2 and Graal with JDK 9. The important part of this graph is that they are all the same. Right? That's exactly what we want. Good. Let's go to the first one. So the tweet service is using parallel GC. So we're looking at parallel scavenge cycles. And this is a moving average of 60 minutes. So it's kind of to smooth it out a little bit so it's easier to see. And what we would like to have, as I said earlier, escape analysis, and now I kind of have to explain what it is. Escape analysis tries to get rid of temporary allocations that you don't need. So it should reduce your GC pressure. So if Graal's escape analysis implementation is actually better than C2's, this should be lower. Okay, let's see what we have. It is. Oh, that's great. And then we see C2 for JDK9 is about the same, and exactly the same for JDK9 here as well. So we reduced the GCs we're doing by roughly 2.5%. It's not a lot, but it's still something. If you have to do less GCs, that's always good. And everyone has a problem with GC, right? So this is great. This is a good result. One thing I have to throw in, because when I talk, or did talk to our service owners, they're monitoring their service really closely, right? They look at everything, at every metric that changes. And one thing where some of them yelled out and said, oh my God, memory leak. They said, oh, old gen uses more memory. That's true, and it uses about 40 megabytes of memory more. But that's because Graal is a Java application. It has some static state, right? You have to store stuff somewhere, like configuration and objects and things like this. So it's about 40 megs, but it's not, it's always 40 megs. It's not a percentage of your old gen. It's 40 megs because that's the state. If your old gen is 200 megabytes, it's 40 megs. If your old gen is 3 terabytes, it's 40 megs. Doesn't change. So it's not a memory leak, but I should point that out. The same is true, but I don't have a graph for this because it's hard to graph it out, or because we don't have it. Meta space is the same, because you have to load in Java code, right? It's Java classes, Java methods. You have to use some meta space, and that's between 20 and 30 megabytes. But that's not an issue. Okay, here's the most important one. So we are looking at user CPU time, and so we want user CPU time definitely to be lower. The way we look at it here, since they're all getting the same requests, we want to do the same amount of work, but doing less work, okay? So let's see. Oh yeah, that's pretty good. You can't see right now how much it is, right? Because I can tell you. This one seems to be a little better, but I don't think it is. That can happen when inlining decisions are taken differently between 2 runs. So I think they're actually the same. It's interesting. And then you can see JDK9 with Growl is exactly the same as with 8. People hopefully are not throwing up now when stuff is going up and down. So we can look at this on a ratio basis, and then I can show you a y-axis, right? And now you can already kind of see how much that really is, and it's 11%. 11% less CPU doing the same amount of work, which is amazing. I mean, I don't know how many compiler engineers are in this room, but 11% are huge. When we do work and we want to improve something and we get 1% of improvement, that's already great. If you get 2, that's like a lottery win almost, but 11 is like ridiculous, right? So that's a good result. So the tweet service today runs 100% on Graal in production for, I think, 10 months now. And yeah, you should try that out right now if I'm not lying. At least I didn't lose any tweets in the last 10 months, did you? No? Everything cool? Everything works? Great. So, and then the tweet service is not the only one. All the other ones I mentioned earlier, like the social graph, the user graph, the user service, they are all using Graal as well, 100% in production for this amount of time. And the bugs I showed you earlier, we have not found a bug since. So we are restarting the services all the time, Jit compilations happening, millions and millions of tweets. It's all good. It's all working fine. So the question I was asking myself was, because I know that escape analysis is better in Graal than in C2, I wanted to know if escape analysis is what's reducing the CPU utilization. So what I did was I ran a tweet service again, and I turned off escape analysis in both compilers, in C2 and Graal. And this graph now looks different because it was a different run, and I'm only doing C2 and Graal. So this looks like this. We look at the scavenge cycles again with no escape analysis. So technically, if we have turned it on for both compilers, this graph should be the same, which it is. Okay, there is no escape analysis going on, no objects being eliminated. We have the same allocation pattern. Good. So let's look at CPU time, what the result is here. And there's actually an improvement. And this improvement, going to the ratio again, is 5%, which tells us that just the inlining implementation of Graal is 5% better than C2's, which is also very good, because the part that where escape analysis can shine is when your application is written in a way that it can actually do that. Some applications, I don't know, worst example I have is if you do matrix multiplication, right? Nothing can be eliminated there. You're just doing numerical stuff, right? But inlining brought us here just 5%. That's really, really good. So how much money is that, right? I can't tell you, obviously. I couldn't show you a y-axis. Why do you think I can tell you how much money we're saving? So I thought we'd do a small, thought example. So we make up this company that does not exist, and we do a little back of the envelope calculation. So I looked up a bunch of cloud providers. I don't know if you guys use cloud providers or if you have your own machines, or I don't know how you run your business. So I looked up a few of them on Google, and they're all printed out in a weird way. And so basically I calculated it out for you. And it's between $72 per year per CPU core and $210. So what you should take away from this talk, if nothing else, please pick your cloud provider wisely, because otherwise you're wasting so much money, everything else doesn't matter. So we take an average here, because I'm not sure which one you're going to pick. So we say, okay, it's about $127 per year per CPU core that you would have to pay to run. So the question is, how many cores are we talking about here, right? I did a little Googling, and there is a Bloomberg article from 2014. It's already kind of, 3 years old now. And it says something like, puts Amazon, and a conservative estimate puts Amazon at over 1.5 million servers globally. They're thinking maybe even 2 million. And then down here, Microsoft had over 1 million servers with its data centers, blah, blah, blah. Google had even more. Big, right? Lots of machines, and they're talking about servers, and that means every server has, what, 24 cores? That's a ridiculous amount of numbers that we're talking. Twitter's not quite that big, but we have a good size. So I'm assuming that our company is slightly smaller than Google. So we're just saying, okay, let's say we have 10,000 servers, and then we say every server has 24 cores. So we say $127 per year per CPU core times 24 times 10,000, it's $3 million just to run your business, whatever your business is, okay? If you can save 11% of that, that's a nice chunk of money. It's definitely more than I get paid. I don't know how much you guys get paid, but this is more than I get paid. So if you could save that, and people in this room who are familiar with how your business works and how many machines you have, you can kind of in your head say, okay, yeah, I could save a little bit here and there. And it's always, the way I like to say it is the money you have to pay to run your business on machines is always like a fraction of your income as well, like what your company makes. So if you, let's say if you only have 10 servers, and you can save still 10%, it's like, I don't know, you save $100 or $200 per year, that's already a cool party. Yeah? Buy some beer and have fun, right? You shouldn't waste it if you don't have to. Okay, so can we get more performance out of Graal? That would be nice. So one thing I did was I was sitting down in the afternoon because I was interested, and I thought, okay, I'll just play around a little bit with the inlining parameters that Graal has, and let's see where I can go with that. So I did that. It's the same run that we did earlier, so you remember this graph, and then there's another color in here called my experiment, which is the purple color here. And we're looking at the scavenge cycles again, and if that would be a little lower, that would be nice. And it actually is. So it's just literally, I think, 2 or 3 hours hand tuning parameters, and I got out another 1.3 to 1.5% less GCs. Okay. Not now. And user CPU time, same thing. It's an additional 2%. And it was just a few hours of work. You don't want to do this manually, right? But there's something called machine learning that could do this for us, which is actually something we're working on right now. and my next talk will be about that topic. So I'm not going into detail about this now, but already 2% is great. You know, remember the last slide we had, what like 1% was $30,000, so that's $60,000 right there. That would be a nice vacation. So for you, I'm assuming, correct me if I'm wrong, but I'm assuming you all don't have your own VM team. Yeah, okay, that's what I thought. So official support for you is kind of important, right? So JDK 9 already contains Graal, I told you earlier, because of AOT. And it actually, I made it that way that you can use it as a Jit compiler. No one knew, but I did it that way. And since 10 is out, oh no, I think that's the next slide. And it can be used as a Jit compiler, but just enabling these. So you have to unlock experimental VM options because JVM-CI is still experimental. You enable JVM-CI, and then you tell it, use the JVM-CI compiler. I tweeted this out at one point. You can find it either in, this talk will be on YouTube as well, but there are a bunch of the same one, and you can look all this up. Exactly, like this talk. The Graal, how to use the new JVM Jit compiler in real life. That it will explain to you step by step how to use Graal, what to look out for. It's like the talk I'm giving is, I'm firing up a cloud instance from scratch. It has nothing installed. And I download Java and I install everything and show to you exactly what you have to do and what to look out for. So it's a good thing to watch. And then, that's what I wanted to say, Chapter 317, experimental Java-based Jit compiler in, oh, I didn't even say it here. It's JDK 10. And it's out, right? It's like March 20th, so that's out. It's still experimental, but at least there is some support from Oracle for it, right? And this move to have this chap and put it in as experimental Jit compiler means that Oracle is actually, committing to it. I cannot exactly say what Oracle's going to do. They could still drop it in the next release. You never know. But all the signs point at this will be the new default Jit compiler, hopefully. That's my goal. Fingers crossed. OK, and then there's this, which is called Project Metropolis, was proposed last year, September last year, by John Rose. We were talking about this for a bunch of times, for a couple of years already now. Because what we would like to do is, here, for using the Graal compiler and AOT static compilation technology to replace the Hotspot server compiler, that's C2, and possibly other components of Hotspot. And so what we would like to do is write more components of the JVM in Java. The simplest one is the compiler. And that's what Graal is. And the reason why it's the simplest one is because the compiler is an optional module of the JVM. You don't need it to execute Java code. You can still run Java code in the VM, interpret it. It would be freakishly slow. Like, everyone would hate Java, but it would run. It would be perfectly fine. So this one's the perfect module to try out, and that's what we did. We tried the compiler first, and then there can be other things like, one example that John is always talking about is the bytecode verifier. Write the bytecode verifier in Java and then compile it down to AOT code. Or one thing I would like to see in my lifetime would be to write the bytecode interpreter in Java and AOT compile it. That would be amazing. So things like that. And this project's out now, open. I'm not sure if Oracle's actively working on it, but it would be cool. And then, this is my last slide, actually. So as I said, most of our services are written in Scala. And I have to be that honest, that's the main reason why we're seeing this improvement. And the reason is Scala, I don't know how many people in here use Scala and Java. Scala compiles to different bytecode than Java does. I'd like to say in my talks, in my presentations, that Java is a little more static than Scala. That's not really true, right? Don't take it too literally. But it's like when you look at the bytecode that Java has, it's much more simpler and easier to understand than the thing that Scala does. And Graal, and on top of it, Scala has a more polymorphic nature to it. Like, there's more polymorphism going on. And the way Graal, the inlining implementation that Graal has, can better handle that. And you saw that earlier when we just got 5% out just through inlining. With Java, it's a different story. I like to say it's a 50-50 chance if it's better or not. most of the time what I've seen, it's about the same performance, which is, from my point of view, already a win, because I told you earlier about the whole thing that C2 is old and hard to understand and learn. So if we can replace C2 with something else that works as good, that's already a win for us. And then we can move forward, write more optimizations, and so on and so on. So, but I've also seen Java benchmarks where Growl was actually faster. So it's up to you to give it a try and tell me if it works or not. So I'm giving these presentations mostly because I want to encourage people to give it a try. For 2 reasons, or 3. The number 1 reason is I would like for you to save money, right? I'm generous. And then the selfish reason is because we want other people to find bugs, right? It would be nice if we find the bugs now before we hit it in production and then Twitter goes down. No one wants that. So that's the main reason why I'm here. So I'm trying to get you guys to give it a shot, whatever you have. Use it, turn it on in production, that would be cool. Well, no one will do that, but you have your pet projects and give it a try, or you have your favorite benchmark, give it a try, run it. That's all I can ask for, really. That was it. Thank you very much. And I'm over, so I'm not sure if I can take questions or not. Probably yes, because they were pointing. Okay, sure. That's small. Is there enough documentation? I can read that. Depends on what you mean by documentation. Do you mean documentation by, is that person in the room? Do you mean documentation for using it as a compiler, or documentation for actually developing Graal, the compiler? Because that's 2 very different things. For the first one, for using it, it's getting better now because Oracle Labs just released Graal VM 1.0, right? And Graal VM is more than I was talking about today. When I talk about Graal, I only talk about Graal, the Jit compiler, and nothing else, not Substrate VM, not Truffle, nothing about this. But through the Graal VM project, I think there's more documentation now for using it. Writing code, I'm not sure how many compiler engineers are in here. That was probably not the question, but for writing, since it's Java, there's some good amount of Java documentation. So that already helps. But there is no book that you can read on Graal as far as I know. Not yet. Maybe I should write one. You said Java 9 contains Graal. Can you give more information about this? It's basically what I said. Through AOT, Graal there's a module. You should watch the talk, the other talk I was pointing out on YouTube. That will explain all this. There's a module in JDK 9 that contains Graal source code, and the command line flags I showed you with enable JVMCI, use JVMCI compiler, that's all you have to do to turn Graal on. That's really it. Do you share any pre-compiled Graal with OpenJDK image setup for the what? Okay, we'll skip that then because I don't know what it is. What is the future plans about Graal VM? Well, we at Twitter, we are not using Graal VM. Graal VM is something very different. It's a marketing term that Oracle Labs is throwing out. And Graal VM, what they mostly are talking about is polyglot, right? They want you to run all the languages on the same JVM, JavaScript and R and you name it, JRuby. But we are only running Scala, Java and Scala code on the JVM. So our Twitter's path will always be use OpenJDK, use hotspot, stock hotspot, but use Graal as the compiler. That's what we are doing. What exactly Oracle Labs is going to do with Graal VM, I don't know, because I'm not affiliated with them. What do you think about Java release cycles? Yeah, that's an issue. I mean, that's something we could talk about for a long time. But the problem, so Twitter, I would like to think that Twitter is a fast-moving, agile company, and even we can do it in 6 months. because it's so difficult to move everyone, especially in a microservice world, to move everyone to the new JDK. And you kind of have to, because you don't want to support 2 or 3 versions at the same time. So for us, we can't do 6 months. And then on top of it, the biggest issue is the security patch situation. If you're not on LTS, you're basically responsible for yourself to backport security patches to a version if you can't move on to the next one, which will very likely happen if you have more than one customer. And by customer, I mean internal customers like service users. So we probably moved from LTS to LTS. Are Graal and Graal VM different technologies? Well, not really. As I just explained, Graal, the compiler, is just part of Graal VM. It's a little unfortunate, in my opinion, that Oracle Labs decided to use that term Graal VM as a marketing term, because it's very confusing. But Graal VM basically means substrate VM, which is the native image compilation, and then you have Truffle on top, which executes, it's a language framework where you can implement language runtimes. And then what else is there? Can't remember now. But Graal is just one part of that, and that's what we are using. And only Graal, the compiler, is part of OpenJDK. Nothing of the other stuff. Truffle, no. Substrate VM, no. Might be Substrate VM might become part of OpenJDK through Project Metropolis. We'll see about that. Was that the last question? Why did it have a -1? No one liked it? It was a good question. Thank you.